Hey guys, welcome back to another low-level learning tutorial. Today we're going to be doing the blink LED tutorial, right, where you make an LED turn on and off forever, but we're going to be doing it in C without the Arduino IDE on Baremetal. The reason we're doing this is because I felt like when I first learned how to do Arduino programming, I was using this IDE, it felt very high level, and there were all these functions that I didn't really understand what they were doing, right? Like I had this pin mode function, this digital write function, and this delay function, but I didn't feel like I learned anything. I felt like I was, writing Python for Arduino, where the actual functionality was taken away from me. So I felt like, did I really learn anything? So to do this tutorial, right, we first need to understand the hardware that exists on the Arduino Uno. So basically, the Arduino Uno is a shield that wraps around this microcontroller. And the microcontroller is called the Atmega 328P, and it is basically a simple microcontroller that has basic in and out functionality, and we want to figure out how do we write output, how do we set the bit high on the pin that controls the LED. Well, if you look at the schematic here, we see that the LED built in is set to PB5, right? What does PB5 mean? Typically when you're dealing with microcontrollers, all of the data in and out is done on these things called ports, right? So you have for here, for example, port D, port B, port C. The ports are registers on the microcontroller that correlate to a set of, in this case, 8, 8, and 7 pins. So for example, port D0 correlates to, let's see if we can find it, port D0 is pin 2 on the chip. So if you set port D0 high, 2 would be hot, it would be 5 volts. And we can use that on port B5, right, where the LED lives, to make the LED turn on. Great. So the question then is, how do we write data to port B5? Well, it's actually not that complicated. So port B is actually a register in the Arduino. A register is 8 bits on this architecture, and each bit correlates to one pin. So if we want to set port B5 to be high, first we have to make sure that port B5 is an output. How do you make the pin an output? You need to use this thing called the data direction register, the DDR. And the DDR in this case is for port B. So if we set DDB for port 5 to 1, that means that the microcontroller is to treat port B5 as an output. Right? So then we want to make port B5 hot, so we write 1 bit to port B5. Great. So at the end of this, we want these 2 bits to be high, and we want the rest of the bits to be low. Great. So how do we set a single bit in a register? This will assume that you know a little bit of bitwise math, but we're going to do this thing where to set bit n of something, we say that the register is equal to the register, so the current value, or 1 shifted left by the bit number. So for example, if we want to set port B5, we're going to say that port B is equal to port B or 1 shifted left by 5, because 1, 2, 3, 4, 5 gets us to this position. And same for DDRB, right? And then to unset it, we do a little bit of complicated bitwise math where we say that the register is equal to the register ended with the ones complement, so the inverse of the same math, right? So we're making sure that when we unset something, all of these bits are left alone and the bit in question is turned off. If you don't get the bitwise math, that's okay. Just understand that we're going to be using this notation to turn something on and this notation to turn something off. Great. So let's get into programming here. So just to prove that I don't already have this figured out, here's my Arduino. The L over here, the LED, is off. Great. So we are going to write some code. Before you start this, make sure you install these libraries or these packages. So avr libc, avr-dude, binutils avr, and gcc avr. Avr is just like the architecture name for the Atmega 328P. Go ahead and install those. I already have them, so you won't have to. Great. And then I also wrote this make file that you should copy down. And basically I'll walk through what it actually does after we write our code, but this is a process of compiling our code, copying the code into a flashable format, and then flashing the code to the device. And then I do have the Arduino plugged into my computer, and it shows up as dev T2Y-ACM0. If you're on a computer like a Mac, or you're using this in Windows, this process may be a little different for you. But for me, this is where the USB port is plugged into my computer that touches the Arduino. All right, so like I said before, to do this, we have to do this in 2 steps. We have to first set the PB5, where the LED lives, as an output. How do we do that? We need to make sure that the direction register for that pin is set to 1 to make it an output. So how do we set DDB5 on DDRB? So the way we do that is we set DDRB equal to its current value ORed with 1 left shifted by DDB5. This may seem a bit complicated, but basically all we're doing is we're saying that DDRB, the direction register for port B, is equal to itself ORed with, so we're setting a single bit, 1 left shifted by the bit number for DDB5. You can actually read into the header files for the particular board that you're writing to, but basically this one line will set port B5 equal to an output. So now we need to say, while serving forever, do the following thing. We want to set port B5. So how do we set the bit on port B5? We do what we did up there, but with port B instead. So port B is equal to port B ORed with 1 left shifted by port B5. That turns on port B. Then we need to wait a little bit. I'm messing up these comments here. Hold on. There we go. Now we need to wait, right? And there's actually a cool macro that comes from the util delay.h library. It's called delay ms, and this is actually pretty interesting. The way that this library works is that you give it a number and it calculates based on the clock cycle or the clock speed of the microprocessor how many no operations need to happen to equate to that much real life time. Thought that was pretty neat. So basically this is just a loop that loops over a no op, a do nothing operation until the amount of time you've requested has elapsed. I thought that was pretty neat. Okay, so now that we've waited some amount of time, we need to say that port B is equal to port B ANDed with, so we're turning off a bit, the ones complement or the inverse of the same value up there, right? 1 left shifted by port B5. And then wait some more. Delay ms 1000. Good. And then we're gonna go through a build process, right? So I'll walk through what this actually is doing real quick. So what we're doing here is we are, let me make sure this is the right size for you guys. View, zoom in. We are saying, hey, AVR GCC, optimize for speed and define the clock speed of the processor as 16 megahertz, which is the clock speed that the Arduino Uno has. If you look at the crystal on the board, it says 16 megahertz. Define the machine type or the microcontroller type as the Atmega 328P. Only compile, so don't create an ELF yet, and output LED0, the ELF object from our source code, right? And my source code is called led.c. Secondly, go through the full linking process and produce led.bin from our object file. And then we go through this obj copy. So this is kind of interesting. The way that AVRDude, the program that is going to flash our code to the Arduino, has to take in data is in the Intel hex format. I did some reading on the Intel hex format. It's pretty interesting. I won't go into it in this video. But basically what we're doing here is we are taking the output ELF from our compilation process. We are removing the EEPROM section, and we are outputting it as Intel hex, the format, to led.hex. And then finally, we are asking AVRDude, which is a program that we use to flash the device, to use Arduino, the Arduino programming process on this device. The port is the device path, right? So where my USB lives in Linux, the serial baud rate to perform this write, and then the source of the data, right? So there's a specific format to this, but we're basically writing to flash, which is writable memory, the file led.hex, which is our output from the compilation process. So if we write this, I'm gonna get my Arduino view ready. We're gonna type in make and hit enter. And now we should have a program running that is flashing this LED once every second. So that's it for the tutorial, guys. Thanks for watching. Really hope you enjoyed. If I missed anything, if there's something you didn't understand, drop a comment and let me know. Otherwise, please hit that like button, hit subscribe. I'll be going into a deeper tutorial series on doing Arduino bare metal programming. Thanks for your time, and I hope you learned something. Thank you. Bye-bye.